Hello, I'm Bill, and thank you for inviting me. The grand plan that Alexi and I hatched was that I would unveil the new release of ScalaTest 3.0. But have you ever seen on TV or movies those kind of, it's like you're running through this dark tunnel and there's light at the end, but the farther you go, the farther away that light gets? That's kind of what this project has been like. So it isn't finished. And in fact, there's some things I'll talk about today that I wouldn't mind getting some feedback on. So it's kind of could be a bit of a design review, but there's a lot to talk about, and I don't want to take too much time because there's another speaker. But what my challenge I felt was that there's a lot of people using ScalaTests. People are pretty happy with it. I would like to try to make it better, but without screwing it up. And I was mindful of a story that I was told by Jim Waldo, who created Genie. Is this one on, by the way? This is probably for that, right? OK. Created Genie, and at one point, when I first saw Genie, it was really beautifully simple, and I was quite attracted to it. And then at one point in its development, they added security. And it had no security. It allowed things to connect, and there was no way to decide if you trusted that thing. And it was sold to the market as a way for things in the world to connect to each other, so security was important. It wasn't sold to the market as an enterprise technology that would be behind a firewall where security wouldn't be needed, because the firewall would provide the security. So they solved, it was a really hard problem, and they solved it, but it just sort of added so much complexity that it kind of screwed up that simplicity. And Genie didn't really work out in the market. It just didn't happen. And he's in Boston now. He's the CTO of Harvard. And me and Kim Arnold and Kim Arnold designed Java Spaces, were having beer one night. It was kind of like three old guys talking about why things didn't work out. It's kind of depressing. But what he said was that he thought it was a mistake to do that, because to actually add that feature to solve that problem was a mistake. And because he lost the essence of simplicity that it had. And that's what I'm worried about with ScalaTests, is it's already in 2.0 is pretty big, and I like small things. So I'm worried that what I do will make it worse somehow, right? So I'm going to give you an example where 2 summers ago I was already working on 3.0, and what I was going to try to solve was the fact that 1 should equal 1 compiles. When an int and a string is compared for quality, that can never be true. And it just wastes people's time. That test will fail, and then they fix it, right? So I did find a way, and it was really hard because of in matchers to combine matchers. It made it very difficult to do that. You had to partially apply a type, and that's not so easy in Scala. But I figured out a way, and that is actually in the master branch of ScalaTest. If you check that out and build it and then go to the console and type that, you'll get that error. And it will tell you that it couldn't find evidence that string can equal int, which is not too unreadable. One thing I didn't like about it was that the string's on the right-hand side and the int's on the left in the expression, but in the error message it's reversed. So that was, I thought, not nice. But the real problem was that it took much longer to compile. And so I checked it into master saying, well, I'm going to make it faster. And for months I tried to make it faster, and I just couldn't make it fast enough, because there's so many of these. There's so much test code out there. And all you do is write assertions, right? So I can't just say, hey, ScalaTest 3.0 now 3 times slower to compile. It's not a good, it doesn't work. So I just couldn't do it. So I actually didn't do that. And the last summer, I tried a different approach, was to make a compiler plugin that checks that stuff. So that actually gives a nicer error message, because I can make whatever error message I want. And you can't tell that it's running. I mean, when you measure the compile time, it actually was, it has to be somewhat slower because it's doing more, but it's not really perceptible. We couldn't measure it. And I think the reason is because implicits are kind of a blunt instrument. And whenever you use implicits, it has to search through all of them. Whereas a compiler plugin, you can just go in with a surgical instrument and find out what you're looking for. So anyway, that's one thing I didn't do, just because of that thing. I think that might have screwed it up, because there was just a lot more complexity and it slowed down the compile. So this is it's in SuperSafe, which is a product, but this stuff is free. So there's like IntelliJ has a community edition that's free. There's a community edition of SuperSafe that's free. So all the ScalaTest assertions and equality, like triple equals and the shoulds and the musts are just, now don't compile if you use that plugin. So the main beast that I've been wrestling with in the last year is Scala.js, and I don't mean that it's a beast, but porting a 8-year-old library that was written for the JVM back when Scala, originally didn't have a lot of things, like there was no future to Scala. For example, that didn't come into 2.10, right? So we really used a lot of the JVM stuff. So for example, we internationalized strings using the Java's string internationalization stuff. And I thought I was being a good boy, right? You're supposed to do that. But it doesn't work on Scala.js. So to port ScalaTest to Scala.js, I had to actually write a internationalization framework. And that, I think, is sort of the definition of yak shave, right? So we shaved that yak, and we didn't make a general one. We just got ours working. But one nice thing that happened out of that is that because we're using Java's string internationalization framework, it was a runtime error if there was a non-existent string. Like you say, I want to use this string, and it's not there, which is crazy. So we did also solve that. So now that's a compiler error. So then another one was ScalaCheck. The one Scala library that we integrate with is ScalaCheck, and that I try to keep dependencies to a minimum because it's easier for users. But ScalaCheck is, ScalaCheck, so I integrate with that, and it didn't work on Scala.js. I figured it would eventually, but we have ScalaCheck tests in our own project testing ScalaTest. So there was another property test framework called Nyaya, good name. So we ported to that, and there's a guy in Malaysia who helps with ScalaTest, and so he was supposed to do that because it said it worked, right? So I got up the next morning. He spent the whole day trying to get it to work, but then he finally did. So I was like, if he's going to spend a day getting something to work, he'd probably try to spend a day getting ScalaCheck to work on Scala.js. So we used that for a while, and then that didn't work, and ScalaCheck still didn't work. So I said, I know, we'll just write our own property-based testing framework so that we can port ScalaTest to Scala.js. So we did that, but just enough to get our stuff working, right? So again, it's not a general thing. And then ScalaCheck started working, so then we went back to that. So that's just 2 examples. We thought it would take 9 days to port ScalaTest to Scala.js. That's what we figured. And it's been over a year, and it's still not done. So anyway, we've shaved several yaks, or this yak several times, and it doesn't look actually like it's too happy about having its picture taken even. But that's really been what has been holding up 3.0. And there's some other things that have nothing to do with Scala.js and 3.0 that have been kind of stuck behind this. I want to just give you a couple simple slides of background so you know what we started with. This is this is an AST that models the outcome of a test. And so a test, when you execute it in ScalaTest, can either succeed, fail, cancel, or be pending. And succeeded and pending are singleton objects. So if a test passes, you don't actually want to know anything. So you just get back a singleton. If pending is, again, if this test is pending, that's just a singleton. But if it fails or canceled, people want a stack trace, right? So that actually holds on to an exception. Canceled is always going to be test canceled exception, but failed is any throwable except sweet aborting exceptions, like out of memory error. There are certain errors that will actually cause the whole run to abort. And not just a test to fail. So that's what was added in 2.0 to model a test result. And with fixture, I in 2.0 changed the signature to have people deal with outcomes. So what with fixture is it's a lifecycle method on Suite that users can override to do something at the beginning and or end of a test. And you can do all kinds of things because the test hasn't completed when the test function returns. The with fixture has passed a function that takes no parameters and returns outcome. So that is, whatever you express as your test, it gets wrapped into this function and passed into with fixture so you can manipulate it somehow. And so the idiomatic, the default implementation in Suite just invokes it. So the job of with fixture is to invoke the test function. So that one just invokes it. The test function returns an outcome, either succeeded, failed, canceled, or pending. And this with fixture just returns it back to run test, which is calling with fixture. So users can override these in their suite and do something before and after, for example. So you can set up a fixture, then invoke the test function in a try, and then finally you do cleanup, so you ensure no matter what happens, that will get cleaned up. Right? That was the idiom I recommended to folks. But the idea of with fixture is it's kind of like function composition, that you can mix multiple traits that override with fixture together and then actually compose the with fixture functions. So instead of actually invoking tests like that in the dark black, what I recommend people do is say super with fixture test, which is you call the super implementation of with fixture and pass the test function up and let it invoke it. So if it's trait suite, then trait suite will invoke it. If it's some other trait that has overridden with fixture, then that will probably call super with fixture test, and then that guy will invoke it. So that was the idea, is you can sort of compose these traits. You can add different behaviors to do things, all different kinds of things at the beginning and end of tests or around the test function. OK, so that was 2.0. And that's what actually everybody's using these days, unless you're on one of the milestones for 3. And then I also, one of the problems with like the way JUnit did things with setup and teardown is that it requires a side effect, and that's very unfunctional. So what you can do, a setup and teardown kind of thing in a with fixture like this. So your setup fixture could create some value and stick it in a var, and the cleanup fixture can clean it up if you want. But what I did from early on in 1.0 is I had another kind of style, another kind of suite that was fixture suite, where you can declare a type of a fixture parameter that's passed into each test in that suite. So fixture suite is a subtype of suite, and fixture suite has this abstract type fixture parameter, and it has another with fixture method. It's overloaded, that has a different signature. It takes a function 1, not a function 0, and it's a fixture param to outcome, and it returns an outcome. And then there is no implementation because I don't know what fixture param is. Right? I don't know how to create one and pass it in. So these don't stack. You would just make one. It's sort of the endpoint. And the reason they don't stack is the fixture params can be different in each one. Right? Technically, you could, if you actually had the same fixture param, make it your own stack if you wanted. But in general, it's not going to stack. OK, so that's another thing. And what you might do in your own test suite is override with fixture with fixture takes a test function that's fixture param to outcome. So what I've done here is I've fixed, I've set the abstract type to string, and then I just create my fixture as the string hello. And then I pass it in the test. So when I invoke the test, I pass the fixture into it. And now all the tests get that hello string passed to it. So there's no side effect needed. But the same kind of thing happens. You can do that in a try, and then finally do the cleanup. Yeah, so that's basically how you use it. OK. So an example of there's kind of two things you can do. One is you can just do this in your test class itself, and that's usually how people override with fixtures, just right in the test class. But if you find yourself implementing the same thing over and over, you can pull it out into a trait. And the way that would look is there's actually one in ScalaTest called severed stack traces way back when IDEs did not actually know how to use the stack depth that's in the test failed exception in ScalaTest and get rid of the ScalaTest part of the stack trace. If you mixed in this trait, it would do that. So it actually did kind of have a side effect. But what it did is exceptional, basically in your super with fixture test, asks the superclass implementation of with fixture to invoke the test function. And what comes back is the outcome. And then you have a pattern match on whether it's exceptional or not. So exceptional means it's either test failed or it's either failed or canceled because it has an exception in it. And usually an exception's bad, but in a test, it's actually good because you just found a bug, right? So I called it exceptional. And so if it is either a failed or a canceled, then you grab the stack depth that's inside there and you sever it. And so that's what, it just chops off the top part. So that's an example of overriding with fixture in a trait. And so what you say is that this severed stack traces trait extends sweet mixin, which has an abstract with fixture. And then you have the self type of suite, so you're going to mix it into a suite that has actually implemented that thing. So what I do in the case of if it's either succeeded or pending, I just continue and return succeeded and pending. Okay.
So this severs it to your code as opposed to like the framework stack trace?
Like if you do an assert and that fails, when you called assert, it called into ScalaTest, so that got onto the stack. That actually gets onto the stack. And what ScalaTest's test failed exception has in it is a depth. Like you go 3 down, that's your code, the one that actually failed. So what this does is it just chops off the top 3, which, right? Because it just there's a stack depth in the test failed exception. So you for better or worse, Java exception classes are mutable, so you can mutate them, even if actually I'm not sure if I can mutate the stack trace. But if I can't, what I do is I make a new. No, I can't. I can't make a new one. I mutate the stack trace. That's what you do. And there's a way to do that in Java. So I just mutate the stack trace on the way out. So anyway, what this is an example of is users can have these sweet mix-in traits that you override with fixture and mix into a bunch of classes. And you get the same with fixture in all of those classes. OK, so that existed. And I have to tell you that Monday I came back from 2.5 weeks in Asia. So when I hit this slide, that's when I remembered that. So let me see what the heck I was trying to get at with this guy. Yeah, this is just an example of implementing, and I think it's another example. It might be redundant. This is an example of you can override, you can extend a fixture suite and define the fixture param, the string. So users would do this usually not in a mix-in trait, but in their own class. That's an example of. And you don't usually call another with fixture that takes a fixture parameter. But what you might want to do is call the other with fixture up here that takes no parameters. So there's 2 with fixtures down here in a fixture suite. There's the one you inherit from regular suite that takes no parameters. It's like no arg test is what that's called. And there's one down here that takes 1 parameter. So they're both. And if you override the one in here, you may actually want to call the one with no parameters because someone may have mixed in, for example, severed stack traces, and you'd want to have that behavior. So what I ask people to do in the documentation is do it that way. So instead of just saying with fixture and pass or test and pass in your fixture object, you call the other with fixture method, and you convert this test to a no arg test. And to do that, you have to give it the fixture. So that's what there's just lots of code out there, people doing these kinds of things that I want to keep working. The other thing that was kind of inconsistent and I'm not sure how it happened, I don't remember, but I know that I made the type of the test body. Most of the styles in ScalaTests register tests at construction time as a function, as a biname. And in 2.x and in 1.x, it was type unit, so it's a biname to unit. And I think I did that just because in JUnit it was void, and I said, well, that's unit, so I made it that. But over here in a fixture suite, you register fixture param not to unit, but to any, and I don't remember why I did that. I may have had a problem with unit down there, but I thought that was weird, that it was inconsistent or just not as nice. So in 3.0, I wanted to make that consistent, but I didn't know which direction to go. Does anybody have an opinion? Before I tell you what I ended up doing. Any? Yeah. How many any's? Okay, how many units? No, only 1 unit. Oh no, 2 units, because it was been a better joke if it was just 1 unit. But anyway, I thought, so I actually agreed with you guys. I made it unit, and then I heard from users. I'll get to that later, but it's actually any. So I did go through a unit phase, but it's any. So that's another thing that was in existence. And this is the type of, like, see the body in comment there? That by name is unit in a regular fun suite. In a fixture fun suite, that is not a by name, it's actual regular function, fixture param to any in 2.0. Okay, so to summarize 2.0, users can define with fixture methods. The with fixture method in fixture suites that take a fixture param can delegate to the with fixture that takes no arguments, and I recommend that in the documentation. And importantly, according to the types, the test is already completed when the test function returns. So if you look at the type of the test function, it's either fixture param to outcome or empty parens to outcome. The result is outcome. So the test has either succeeded, failed, canceled, or pending. It's done, right? It's baked into the types. And the test body result types are inconsistent. There's unit and there's any, right? Okay. So I actually was teaching play, like TypeSafe's play course 2 years ago or something. And I was repeating the mantra that there's 3 rules of reactive programming. Rule number 1 is never ever block. You've probably heard TypeSafe people say that. Rule number 2 is never ever block. And rule number 3 is, well, okay, maybe it is not so terrible to block sometimes in your tests. So that's a wishy-washy rule that they kind of try to like not put in red. But I was like repeating that because I'm supposed to in the class. And then I got to wondering, well, why is that true? Why is it okay to block in your tests? In play or in spray, you can, instead of blocking and finishing a response and then returning a response to the framework, you can return a future response immediately. So why can't you return a future assertion to ScalaTest and let it complete it? Right? So that's what I thought. So I asked the Akka guys, and they thought, well, maybe that's okay. That sounds interesting, whatever. And I kept thinking about it, and I thought, well, that's interesting. And I thought of a way to do it. And on a train ride, I just coded it up and kind of got a proof of concept that it was possible. But it's one of those, like that voice in my head was like, if you add this, are you really solving a problem that adds complexity that isn't really needed? Right? It's that thing of I don't want to screw it up. So I really wasn't going to do it. And every time I'd go to a conference, I'd ask people, what do you think of that? And they'd all kind of say, yeah, that seems like, but there was no burning need, right? So I wasn't going to do it yet. But it turns out that there is one simple fact of JavaScript is you can't block. And I actually didn't understand this right away. When we did our port to Scala.js, I thought I'd gotten to the end of the tunnel. And then I got this issue posted from a guy whose name is Code. And he just showed this simple code here that in our 3.0 milestone didn't work. And the ways JavaScript, I'm not sure how many of you have had the pleasure of using JavaScript, but there's just one thread going around in circles. There's an event queue, and the thread just picks up a job and does it, and the same thread picks up a job and does it, picks up another job and does it. It's kind of like the AWT event thread or the swing event thread. That's how it works. So it's single-threaded. So can't do anything multi-threaded, right? So that's what I thought. So all of our tests passed, and we actually had ScalaTests working on Scala.js last summer. And I was about to release RC1, thinking, hey, I'm almost there. And what this guy did is he actually had the audacity to call into an API. So what you can do from JavaScript is call into an API that is now outside of the JavaScript VM or whatever you call it. It can be a C thread, a different thread that does something. And when it finishes, like maybe it goes out on the net and does a request. And when something comes back, it sticks a job on the JavaScript's event queue. And then eventually that one JavaScript bed's going to pick it up, right? So what we had for futures, and they did port futures to Scala.js. It's pretty interesting. was this Scala futures trait that has blocking things. So like here it is called future value, x.future value. Future value blocks until the future named x is finished, and then it returns a value. And if it doesn't complete in a certain amount of time, with your patience configuration, it blows up with test failed exception. Or if the future fails, it also throws that failure. So that's what future value does. So on Scala.js, it didn't wait because you can't block in JavaScript. So it basically did this assertion too soon. The actually really async thing hadn't come back. And when I saw that, I'm like, oh no, I have to do that async testing thing where you can return a feature to the test framework. It's the only way to do it, because then he could actually on the X future, he could map an assertion, and ScalaTest would just hold on to it. Just like when play is given back a future response, it just holds on to it. When that feature completes, it sends the response. What ScalaTest would do is when that feature completes, it performs the assertion, and then at that time, it does an event to the reporter saying test succeeded or test failed, right? So that's actually what's taken another 6 months, was async testing to get that to work. So the first problem is future of what? So I say future of assertion, but the type of assert in 2.0 was unit, just like you would expect it is it's always been unit, right? So I didn't like that, and so I really wanted to be able to explain this by saying future, and then in square brackets have something called assertion. So what I did is I made a type alias assertion that's the one and only one succeeded singleton. So now when you type assert x equals 1 and it's valid, you actually get a succeeded singleton back instead of the unit singleton, right? And it actually looks pretty. But now, and the same thing, so we went through and did that for both assertions and matchers, right? They all return this. They have result type assertion, and it returns the succeeded singleton, or it throws an exception, because they would break code if I made it not throw an exception. So it still throws an exception, same exception as before, if it fails, but instead of returning the unit value singleton, it now returns the succeeded singleton. Okay. So what you can then do is we made, we couldn't make a trait that mixes into FunSuite to make it async, because FunSuite has a with fixture that assumes the test is finished when it completes, right? So that wouldn't work. So one thing I could do is break all that, which I can't, but I could, and redefine it. But what I did is I made a different style trait called async FunSuite, async prop spec, async word spec, where the type of the test body is future assertion. So if I have a future, then I just map onto that value and assert, and that is now a future. The type of that is future assertion, and that's what it's being looked for by the test body. So that will compile, and it just, behind the scenes, when that feature completes, it'll fire the events to the reporter. Okay, so that worked. That actually solved the problem. That got, it fixed that guy's problem. So instead of using Scala futures, you just use an async testing style. And these guys, as I mentioned, won't work because the test result type is outcome. And I really need a future outcome or something like that, right? So I really struggled with how to do this because originally in Async Test Suite, I added an overloaded one and made the original one final. But there was, again, I was about thinking I was finished, and Heiko Seeberger said, hey, how can you limit the time that you wait for a feature to complete once I give it back to you? I'm like, I don't know. So when I finally went through that process, I realized I need to do one small break, which is I made two subtypes of suite. I took with fixture out of suite, and I moved it down to two new traits called test suite and async test suite. And what test suite does is it adds the type of a test to it. So the type of a test in test suite is empty parens to outcome. The type of a test in async test suite is empty parens to future outcome. So so there's two different with fixtures down there. So originally it was future square brackets outcome, but then it was actually quite clunky to transform it in the with fixture method. You've got to actually transform the future. And so if you want to handle if the test failed, that's actually a future success. So you have to handle success failed. And I thought that would be very confusing for users. So what I actually made while I was in my Asia trip is I made something called future outcome, where the methods are on succeeded then, on failed then. So they actually fit the domain of testing. And the other thing they do is that's like a side effect, right? If you want to clean something up. It was actually quite clunky in the future API to handle whether something succeeded or failed to give back a new future that didn't complete until the original feature completed and your callback function completed. You have to say map and recover both, or recover first and then map. Right? Recover handles the failed case, and map handles the other one. So all these methods in future outcome return a new future outcome that will not complete until everything happens. And what I'm trying to do is make the semantics of working in the future space the same as working in the regular space. And so in the regular space, if your cleanup method, like your cleanup code and your finding clause blew up with an exception, actually your test failed with that exception, right? In the futures API, there's a method called and then, where you can register a callback. But if it blows up, it just hides it, right? It's not necessarily wrong, but it's not consistent with the other one. So this guy, if anything you do, like in your callback function, blows up with an exception, now the test fails with that instead, just like it would over there. So yes.
Can I use only async test and wrap it with future, and if I want to do blocking to get? So why do I need, if I'm moving forward, can I use only async test?
You can use only async test if you want, yeah. But if you call get, you need to come up with a future somehow to, oh no, you don't. There's also an implicit conversion from assertion to future assertion. So if you just want to have one that's synchronous mixed in, you can. In other words, in an async testing style, you can have both tests that return future assertion and tests that return assertion mixed together. That's okay.
Moving forward, test with deprecate.
No. There's millions of lines of code out there that would be upset if I did that. So that's one of the things, like even starting from scratch, let's say I was starting from scratch, I could do just the async one because it's more general. Because a synchronous test is a special case of the async where the future is already completed, right, as you pointed out. But what that would mean is that even when no matter what kind of with fixture you're using, you'd always have to be transforming futures. For beginners, I think that's a little bit of a steep hill to climb. But it's kind of moot because there's just too much existing code out there. So I can't. So and this is the fight I've been fighting is like trying to not let it explode. Another example that I think about is Jira. Atlassian's. Has anybody ever? Yeah, that has got so many features. It's so powerful. I can't figure out how to do anything simple. I mean, I only want to do like a handful of things, and I don't want that to happen to this. And it can happen, right? I could screw it up. So like here now, I've exploded my testing styles to two, like double is double, right? So anyway. But that is a breaking change because with fixture used to be up in suite and now it's in test suite. But all you have to do, it won't break any with fixtures you overrode in your test class itself. It'll only break these mix-in traits, which there aren't that many of them, I don't think. And to fix it, you just add the word test where it's dark. So it's just a textual change. It's not too bad. So I think that's going to happen in 3.0. But this hasn't happened yet in a milestone release. I just kind of came up with that name a few weeks ago. OK, so the other thing that didn't really exist nicely on future was a way to do this try finally. So I made a try finally for futures. called cleanup lastly. No, complete lastly. And this is not fixed with font, but when it is, I mean, most times people program with that, they actually line up. Those curly braces line up, so it looks kind of pretty. But complete is like try. And it says complete this futuristic thing. This can be any type T with a futuristic of T type class. So it works for future of any type. And it works for future outcome that I invented, right? So it says if the body in between the complete curly braces blows up with an exception, it will definitely do the cleanup. So if it blows up, if that blows up, otherwise it's going to return some futuristic thing. So it registers the cleanup code to happen after that future completes and returns a new future or futuristic thing. It'll be return a new future outcome in that case that doesn't complete until both the original future completes and the cleanup is finished. And if the cleanup blows up with an exception, that future will have it as the failure, right? So that's now the recommended way to do cleanup in the future, in the async styles. In the current milestone release, it was called with cleanup, and someone told me it looked like a bug so in Japan. So I just changed it to that recently too. I think that's probably what it's going to be. And this is basically what I ended up with. And again, it used to be much simpler. There used to be suite, fixture suite. Now there's 4 other things there that in the surface area. The with fixtures are defined in test suite and async test suite. And then there's that fixture suite that defines this abstract fixture param type. And then now there's fixture test suite and fixture async test suite, again, that add the with fixture. So you'll either go fixture param to outcome or fixture param to feature outcome. So that is what I ended up with. And the last time I gave a talk was in Scala Matsuri in Japan about 3 weeks ago. And I hadn't gotten, I really just still didn't like this because it was too much stuff. I hadn't come up with the names test suite and async test suite yet. But when I saw it on the screen, I was like, well, it looks kind of like a rocket, so maybe it's OK. And I think the name test suite actually works pretty well because I've never used that for anything. And it's an abstraction of suite where the test function is defined. So I think that kind of actually makes sense and is explainable. So another thing that in ScalaTest 1.0 wasn't really going to work. I mean, I had for a long time been thinking there should maybe be a type at the end of a test that's not any or unit, something more strict. And so if there's going to someday be an assertion type at the end of a test, then intercept would not work at the end of a test, because intercept is this thing that will make sure that this code between the curly braces throws an exception. And if it does, it returns it to you so you can perform more assertions. But now that has type, well, this one has type string index out of bounds exception. And I had this other syntax for matchers evaluating this bit of code should produce a string index out of bounds exception. That did the same thing, right? So this one says had, because I actually deprecated that in 2.0 already. Kind of for this reason of I needed to separate checking for an exception that I don't plan to ever look at again, so I don't need it returned, and checking for exception that I also want to do further assertions on. So I deprecated that in 2.0, and that's removed in 3.0. That's been deprecated over 2 years. So now what you have in 2.0, which is the new way to do it, is you can, first of all, if you just want an exception, you can say the string index out of bounds exception thrown by this code, and you get it. You can then perform an assertion on it, like X should have message, blah. That at the end of a test would work because that's an assertion, right? Or if you want to do it together, you can say the string index out of bounds exception thrown by this bit of code should have message, blah. That's an assertion because there's a should there. Or you can just say, if you don't care, you can say a string index out of bounds exception should be thrown by this bit of code, and it doesn't return the exception, that one, because you didn't say you wanted it, right? That one has result type assertion, so that can end a test, right? So in 3.0, I added one more intercept-like thing called assert throws that does the same thing as that last thrown by. It just checks to see if there's an exception, and it doesn't return it. So just assert that this code throws this stuff, and I'm done, right? So now that can end a test. But there are gazillions of tests out there that end in intercept that would break if I just change the result type from any to assertion. and that would really make people mad. Also, these things don't work in they don't work in futures, because in futures there's this difference between failure and success, right? So what was needed was a way to say, I expect this future to fail with this exception. So I had to create these guys, and it's the same kind of thing. The first one, recover to exception if, illegal state exception, if that code in there creates a future, right? Empty actor question mark peak will give you back a future of something. If it fails, I expect it to fail with illegal state exception. If that doesn't, then I will get, this will transform to a future assertion. What will this do? This will transform to a failed future of whatever, I'm not sure what type actually, but it's a failed future. That's where that goes. If it succeeds, then I actually change it to a future exception. So now you have an exception in the future, and which you can do more assertions. You can map assertions onto that exception, right? Recover to succeeded if this future fails with illegal state exception. If that happens, it just gives you a future succeeded, right? So that's a future assertion that can end the test. This one has result type future of illegal state exception. This one has a result type future assertion. So it's kind of like intercept and assert throws for future space, right? So that's defined in Async suite in 3.0. So I had to invent that. And then there's another problem with having a result type of assertion, which is there's something called I called fixture context object. Context is a terrible name for anything, but I couldn't come up with a better one. And what this is this kind of you can make a trait that has something in it, and then your test body can actually just instantiate that, and now you inherit that fixture. It's sort of the fixture is the context your test is in, right? And that is pretty code, and a lot of people wrote code like that because I put it in my documentation, except now the type of the body is buffer. It's not assertion, right? That's one problem. And another problem is there's a lot of external libraries that do different weird things, right? So I can change the assertions in ScalaTest to return type assertion, but the Akka test kit has a bunch of things that return unit or the message type. So expect message actually returns the message. It's like intercept in Akka test kit. So that would not work at the end of a test, and there's just tons of test code out there where that's at the end, right? Okay, so those are some of the issues that I was worried about. So I did add, I mean, there's a fail, a cancel, and a pending in 2.0. In fact, in 1.0, those three existed. So I added succeed. And succeed just is type assertion, and it returns a succeeded singleton. So you can just stick that in the test to solve any of these type errors. But it's actually probably not too painful to do that as you go. But if you had a huge test suite and you have to go in and retrofit, it would be very frustrating for users, I think. And what I did, though, is I actually recently created another thing called assertion, which is org ScalaTest compatible assertion. And currently it's written in Scala because I couldn't get it to do something. But the idea is that would actually be a Java interface, and it would be released in a separate jar. It's just an empty marker interface. So there'll just be 1.0 of that, and there'll never be any other release because it's just an empty marker interface. And unless I have to worry about binary compatibility of Java releases or something, but my hope is I'd never have to release another one, right? So Akka test kit could actually depend on just that jar. ScalaTest compat assert.jar. It has one Java interface in it, and they can actually have their expect no message return some instance of that. And that's what the result type of tests are in ScalaTest. So that it would be more convenient for external libraries like ScalaMock. Its assertions could actually just work at the end of a test, right? And then I also made something called fixture context that's actually a trait. There never was one. I just used like the words fixture context before. Now there's a fixture context trait that extends assertion also. So I can just make trait buffer extends fixture context, and now it is also a compatible assertion, and it can actually, this syntax will now work, right? be readable in new buffer. New buffer makes an instance of buffer, which is a fixture context, which is a compatible assertion, so it will actually work. So I did that, and that was recent. And then what happened with this is, this is currently what we have. I did change those to any, and the reason is when they were unit, so like I said, I first changed them to unit. So they're all unit. They're expecting unit. And Scala is happy to discard any value to unit, so I thought it would be fine. But, and I don't care if it's discarded, because I don't care what it is. As long as it isn't an exception, the test passes, right? But there's a compiler flag in Scala that says warn on value discard, -y, warn on value discard. And if you like have a 3, and you pass it to something that requires unit, it will just stick a semicolon unit there. The compiler will do that, but it will actually warn you. So suddenly everybody got a bunch of warnings because the result type, people who had that flag enabled, the result type that was expected was unit, but an assert at the end was now returning succeeded. It used to return unit. Now it didn't, right? So that's, and then there's another flag you can set saying any kind of warning, make it not compile. So it's like killed everybody's compile. Yes?
I've also had tests where I've had to throw a unit at the end of it. It's like the compiler's like, oh, what type is it supposed to be?
Huh.
And then I'll have to throw, well, for whatever reason it's confused about the type, and I'll have to throw just at the end of my tests, for whatever reason I wrote it with the kind of matcher.
Yeah,
and just throw a unit
that
and that
should.
makes it work. Because obviously if it fails, it's going to throw an exception.
Yeah, that would happen if you were like down here where there's a unit. If it's units required, and you have that flag set, and you have like the flag that not compile set, then it will actually not compile unless you stick a unit there. And that's what people are having to do, is sticking unit everywhere. And so that's why it's any. Any was the right answer eventually. So I switched it to any. But this is still kind of like inconsistent. What I sort of feel like, if I had to start over, is that it should be assertion, fixture param assertion, empty parens assertion, future assertion, right? It should just be assertion everywhere. And I think it wouldn't be that cumbersome if I'd started that way. Yes?
Can I ask you something
Sure.
else?
I'm going to find my.
The first slide that you showed
Yeah.
was that you did not like a string could be equal to an integer, right? Implying, why are we subtyping? But a lot of your other slides are like you're doing a lot of mixing, a lot of subtyping. Do you use this much mixing and subtyping in your actual runtime production code, or is this like something you do only in test framework?
Subtyping is not evil in Scala.
It exists, obviously.
Yeah. But the problem with the equality comparison is just that it's type any. Basically, Java-lang object has an equals method that takes an object. So we didn't have to just integrate with it the way that we did, but we did. And it's actually makes it kind of seamless to use all these Java things, but then you get that type error. I mean,
evil, obviously. We want Java
well, it's
libraries.
not necessary, but it's like if Martin had gone a different direction, then the harder he makes it for Java people 5 years ago, maybe people wouldn't have adopted as much. I don't know.
Missing implicit, like we could have had equals.
Could
we
have,
had an
yeah.
equals type class if we wanted to.
Yes, and you still can. But anyway, that decision was made. I think that basically what I use in ScalaTests is traits. Traits are actually, the way traits work, I think makes OO work, where you can actually do this. You can't do this in Java. It's really, really clunky. But because you can actually have abstract override, that way of mixing traits and overriding the super, calling super even though it's not defined, is what makes all this work. And it's just a kind of function composition. You mix in, and you're like functions are calling each other. So it's kind of an object-oriented way to do function composition. So that it seems to work pretty well in ScalaTest. Anyway, that's what we have, is that. Yes?
Another question.
Sure.
So theoretically, async functions actually should run much faster because you're not blocking on the. If you have multiple awaits, theoretically it's actually going to finish at the longest await.
Abdul, can I do the question?
Yes. That was. He said his theory, in theory, that the async may run faster because it's not blocking.
Because if you have multiple waits.
Right. If you have multiple waits, they're serialized. So Possibly. I didn't believe it. I would never believe that until I tried it, and I've never tried it. I didn't do it because of performance. I did it because of Scala.js. And again, even going back to that original point, I hope someday I don't look back and think it was a mistake to do the Scala.js support, right? Because it's sort of taken me in a bunch of different directions that add a lot of surface area. But anyway, there's a problem with running faster is that what happens faster for sure is the test body completes faster, which returns an assertion. So you could very quickly get 1 million futures trying to compete for each other, and then they'll all time out. That's the problem I did worry about. That was my premature optimizations. I was worried about that. So the default execution context, I made a new one called serial execution context, where when you do your mapping, when you're like transform your future, there's always an execution context implicitly pulled in that's used. The one that's there by default just remembers what you asked it to do, like puts a job in my own queue. And then when the test function returns, before we move on to the next test, we actually go through and have the same thread execute them. And the other thing that does is you don't have to worry by default about synchronizing access from multiple threads. So if you really want multi-threaded in your test, then you just override the execution context and put in global or whatever you want. But if you're using default, if the queue empties, but the test hasn't finished, I block on the JVM. Because otherwise, I could end up, that's how I actually throttle them. So if you can basically say if I have 8 threads, I can just have 8 tests running concurrently so that they each have enough threads available to complete. Or you could throttle it to 16 or whatever. But if you just override all your execution context to global, they'll just all start, and then some of them may time out. But you can tune it, right?
Which means I can't find bugs in multi-threaded application with the default execution context.
Correct. But I actually got the feedback that that wasn't what they wanted. Finding bugs by just hammering threads at it, you can do. Basically, if you want to do something multi-threaded, currently you have to actually select a different execution context. And that also kind of fit with the way I did parallel test execution in the past. I make a new instance so that you don't have to worry about synchronizing different tests' access to instance variables, because people do that. They make vars because they're used to JUnit. So if you run them in parallel, you mix in parallel test execution. Each test runs its own instance, so they can't really clobber each other. So you don't have to think about it. So that's what I did before, and that's how I kind of went this direction as the default. It's not set into stone, though. And in JavaScript, in the current milestone release, I had the queue as the default using the JavaScript queue, but that doesn't actually guarantee the order. So we just changed that to this. So if you actually want to do something truly async currently in like 3.0.x branch in JavaScript, if you have to do anything multi-threaded on either of them, you actually have to set a different execution context. That's basically, I think that might make sense because it's consistent. So, but that one isn't really decided. But anyway, I should move on because I want to let our other speakers have an opportunity here. So I did try actually implicitly converting any assertion to like have FunSuite take type assertion, but old code work. And one problem I have with that is it's an abomination. I don't want to convert any to anything. Even though I do control one type, it just seems kind of wrong philosophically to me. It's too clever or whatever. It seems too prone to confusion. But it also doesn't work because remember I said there's this expect message method in Akka test kit. It infers type M by looking at the message type, and then it returns it. Right? So you say expect the string hello. It's going to infer M to be string, and the result type of expect message is string. So this implicit conversion, what you want it to do is convert the result of expect message, right, to assertion. It basically discards that string and puts a succeeded. But what actually it does is it converts the parameter you've passed to expect message, and the test fails with expected succeeded but got hello, right? So that would break code, and so I mean, for a while I actually had that in there, and it was wrong, so I took that out. And one of the things that isn't going to be in 3.0, but probably later will happen, is this thing called an expectation, which is like an assertion that returns a result and doesn't throw an exception. And I want to put that in there probably for laws testing. And again, it's, I may not ever do it because it might fall into that thing if it's not needed enough. But that's one of the things I'm thinking about is I think this might be nice to have, and it actually works. So we did flesh this out as well just to make sure that it worked like we thought it would, but then I got rid of it because I don't want it in 3.0. I don't want to spend time getting it working and completed and documented and everything. But if something ends in a fact, which is the type alias expectation is equal to a fact, and a fact is either a yes or a no. So it's kind of like Boolean logic, but with error messages. It's not just true and false. It's yes, something happened, right? It's an observation of an experiment that you performed. And it's more than just Boolean logic, though, because it also has an is equivalent to and an implies. So it's really like predicate logic or propositional logic, especially if you add exist and for all in there, which you can use property-based testing for. So you can really make a test as a statement of logic, and it will be a value of type expectation. And then I'm OK with an implicit conversion from expectation to assertion. And that's how that would work. Because when a test fails, they actually want a stack trace. So when you convert an expectation to assertion, if it's a yes, it just gives you succeeded. If it's a no, it throws test failed exception with an error message and a stack depth and all that stuff. So, so anyway, that's kind of one of the use cases for having assertion be the result type. So this idea I just had, I really struggled with how to do it. And I have had an idea that I've never told anybody because I had it a few days ago. These are all the style traits in ScalaTests that you register tests, and so they have type any right now. Perhaps your favorites are among these, maybe not, I don't know. But I have the thought that you could actually deprecate all of them. Deprecate fun suite. And that's absolutely crazy. But I think, if I'm ever going to have a style where the type is assertion, it should be called fun suite. It should be like the name for it. So what I thought I could do is just have this, it's more bloat. But I could ask people, basically when you use fun suite, it still works exactly as before, but you get this deprecation warning that you need to change the name to any fun suite. So it's one of these textual things, but people have to go all over the place, and maybe they could write a script to do it, but it's painful to put people through. But then fun suite and any fun suite are the same thing. The old name gives you the deprecation warning. Down the road, I could change fun suite to have type assertion, and it would be, achievable, I think. But now I've got bloat, and that's it's in an experiment branch. I didn't even put that in 3.0x. So anyway, I would enjoy hearing. You guys didn't run screaming, so maybe it's not too bad. But there's just so much code out there. I hate to make people go through that if I'm not, I just hate to make people go through that kind of thing. Even though it's a deprecation cycle, it's still painful. So anyway, that's my whole thing. I did actually touch on serial execution context. That's the default. So I just thought for Q&A, here's some ideas. There's that thing, if you want to talk about that. Tests actually execute one after another. That was a request. I thought they should run in parallel by default. But even though they're async, a ScalaTest won't start the second test until the first test, its future has completed. And the reason they did that is that basically people are reusing fixtures like a database, and they don't want them running in parallel. And in parallel test execution works, before and after works, so everything is async. And I thought it was async in 2.0 because the after all method in 2.0, I made sure it doesn't execute until all these tests finish in parallel. In 1.0, that wasn't true. But there were bugs in there that weren't hit by people. And then just were features that didn't exist. So we had to do a lot of work to get all that stuff to work. But basically, your async styles, you just mix in the same traits, and it works the same, essentially. Before and after work, it's all async. Parallel text execution even works on Scala.js because if you have a bunch of tests, let's say you have 10 tests in one suite, and each one of those calls into one of those API calls that uses a different thread to call out of the net, and that takes 30 seconds. It's kind of nice to actually get 10 of them going at once, get those 10 asyncs going at once on JavaScript, and so your tests are actually running in parallel. So it even makes sense on JavaScript. So anyway, those are some ideas, but I just appreciate being invited by Alexei, wherever you went, and would welcome any kind of feedback because none of this is actually released final yet, so I can still change it. Thank you.
Let's do maybe one or two questions so we can get any feedback. I'm sure there will be from.
So
Yes.
something happens to me with some of my tests. Love Scala check. You have Scala check integration. Obviously, it's one of your only integrations. But let's say I'm doing something with like a mock framework where I'm expecting mutation or to have like a protocol.
Yep.
I'm expecting certain calls to happen, but each iteration of the Scala check doesn't have its own like cutoff. Now I don't know if this is like probably all this comes down from JUnit, what it means for the end of a test.
Yeah.
Is this something that you'd have to like recreate what it means to have a test, to have a cutoff, and like did your calls get made in this 1 out of 100 loop, or is that something that you can address?
I'm not sure we may have a cutoff. So there's timeouts. So that was.
Well, I mean, it's not a timeout. So let's say I'm saying, all right, I do this call. I expect because I said foo of A,
Yep.
I expect my unit to call some other thing, call like bar with A.
Correct.
So I only will find out if this didn't happen if I'm doing a Scala check at the end. I mean, if it calls the wrong order, yeah.
Right.
But only at the end of my
Oh,
100.
with mocking.
I realized, oh, it didn't actually call any of that shit.
Okay. Yes.
So
it takes
some way to
time.
signal, I'm at the end of a loop. I'm at the end of one property.
Huh.
Is that something that nobody's brought up?
Yes, nobody's brought that up. It's amazing, actually. One of the things I find kind of surprising is people just, I guess maybe because you don't pay for it, no one complains. Until I happen to be there, then they bring it up, and I'm like, well, I was good to know. Like that thing where people were having to put the unit everywhere. I mean, these are good friends of mine, and they were just doing it. But then when I saw them at a conference, says, hey, by the way, I was like, oh, I didn't know that. So I'm sure there's been people who've had that pain, but they just deal with it. But afterwards, maybe you can talk to me about it. Yeah. Is there one more? So I'll let him go. Going once.